Hello everyone. On today's episode of Skills Which I Never Ever Thought Would Be Relevant Again, we're going to fix a CRT television. That is, assuming it's broken. I'm pretty sure it's broken because when I picked it up a bunch of sand fell out of the back. But we'll save that excitement for the testing stage. Yeah, this was a dumpster rescue. I saw the back of it sticking up out of the top of the dumpster, and I asked the guy working there if I could go in there and get it, and without saying a word he climbed in there and grabbed it for me. So that was cool. Got to do some dumpster diving without the actual diving part. How often does that happen? So thanks again, random dumpster man. Anyway, let's get into this thing. Oh, is that what I look like on TV? Yeah, there's no way to hide from that reflection. Not with that 20-inch tube. But yeah, this set doesn't look like much from the front. But if we go ahead and just turn it a little, it's got everyone's favorite. Fake wood grain. Yeah, look at that. Yeah, nothing more reminiscent of electronics from that era, is there? And we've got some signs of use down here. Seems as though they really like to turn the volume down. That silk screen's about completely gone. And of course we have our IR receiver somewhere over here for the remote, which I definitely do not have, but certainly don't need one for the purposes that I'm going to use this thing for. And this is a stereo set. Oh man, combine that with a 4-head VCR, you are set. And here's a looky-loo at the back. I do like that it has a familiar IEC connector for power. I think missing the ground lug makes it a C18 connector. Not too sure. But I do know that my hundreds of C13 cables will work just fine in there. And here's our various adjustments. Not sure how well those show up on camera. They barely show up well to my eyes. And this set does have S-video, so at least we get slightly better options than the RF and composite. Would be cool to do an RGB mod on this thing, if it's possible, depending on how deep down the CRT rabbit hole I go. And here's a good look at the label. Manufactured May 1992. And there's the mark of the beast. Thomson Consumer Electronics. That's who eventually bought RCA, and thus begun their era as a zombie brand. Hey, I wonder if we can get some dealer service. Alright, let's get this thing open. And it looks like we're only 5 screws away. All 1/4-inch hex. Let's get those out of there. See if we get the familiar plastic crack. Oh, not quite. Maybe we'll get lucky on the other ones. Guess that's just not that type of plastic. Gotta figure out a whole new set of camera angles for TVs. Okay, let's see if this thing's ready to pull off. Usually I have to lay it on its face. What is the hold up here? It's not a screw. It's just on there out of habit. Wow, it has been so long since I've seen the inside of one of these. And would you look at this? A parts diagram. A relic of a bygone era. Yeah, you never see that inside a modern TV. No sir. And there's some of that sand. So I'm struggling to figure out how sand got in there, because it doesn't look like it was stored outside. Well, no, I do see some oxidation on that transformer there, so maybe it did spend some time outside. Though at least on the surface, as far as I can see, the chassis looks okay. We'll have to see what the underside looks like, but not seeing many terrible signs here. Now, one of the big metrics with CRTs is the number of hours they've been run. It's kind of like mileage on a car. They aren't making any more of these, you know? At least not for television applications. Now, some modern sets have an hour counter, usually accessed through the OSD menu. Not sure this one does. This might be a little too old for that. But there are some visual clues you can use, like the amount of dust on the high voltage line for the anode. That can kind of be an approximation for a number of times it's been powered on and off, because every time that happens there's a massive electrostatic thing going on, and that just attracts dust like a magnet. Not a perfect indicator because not all environments are equally dusty. You can also get some clues by looking at the neck. Let's actually get this neck board off. You gotta be kind of careful with pulling these off. You don't want to twist them. You just kind of shake them back and forth slightly while pulling. Otherwise, you could air the tube. Just clean that up a bit. And if you peek inside and look at the electron gun, you can look for signs of bluing. That'll tell you if the filament's been run for a long time or not. This set might be too new for that though. This one makes it more difficult because there's tape on here, but I can kinda peek past it, and I see some signs of heavy use. This could be at least a moderately high hour set. I'll have to see how bright the picture is. And I did notice this cool feature. The neck board gives you indicators of what the pins do, so we can actually measure the filament, make sure it's not open. And we just hit those with the ohm meter. And 1.7 ohms, that's a perfectly cromulent resistance for a filament. Basically, you just want to see that it's not open. Okay, now let's work on getting this chassis out of here. And of course, I have to do this socially responsible thing and warn you about the incredibly high voltages that these things operate at. These tubes are basically giant capacitors, and they can store many, many thousands of volts, even after they've been turned off. Now, some sets have bleed down resistors, but you can't rely on that, so you have to discharge them. And the way you do that is with a screwdriver connected to a lead. Just take the end of the lead and connect it to the CRT ground, or DAG ground. It's very important that you go to this one instead of the chassis ground, because otherwise you could blow stuff up. This tube's already discharged. This thing's been powered off for who knows how long. But just for demonstration purposes, you stick this under the suction cup until you hit the center. If it's charged, you hear a spark. Obviously this one's nowhere near charged. Let's hold it there for a couple seconds. It should be good. Let's get that back off of there. I'm going to pull that off. Just got to send it to one side, and then the other, and that's it. Now with disconnected deflection coils, it's important to take note of these because sometimes they're not side specific. Like these are different sizes, it's obvious which one goes where, but in other sets you could easily flip them. It's a good idea to mark them. I don't because I have video footage. Got off that clip there. And what is this? CRT ground. Let's get that off the neck board. That can just stay there. And just disconnect all the other various componentries. Now it looks like we have a retaining screw right here. Get that out. And this whole thing should just pull out. So release these clips. Yeah, here it comes. Man, remember when stuff was easy to work on? Those were the days. Let's see, forgot to disconnect something. It's a degaussing coil. Let's get that out of there. Okay, well, not too bad underneath. Not seeing any terrible corrosion. But something about that 90s RCA circuit board layout definitely triggers me. All the memories of RCA's endemic cold solder joints that plagued a lot of their 90s sets. Now, with that out of the way, let's vacuum this thing out. Now let's go ahead and de-dust this picture tube. And for that I recommend just using a dry microfiber cloth. It's not a good idea to use any solvents on the back of a picture tube, because this aquadag coating is so sensitive that sometimes even water can take it off. So a dry cloth should get us plenty far. And if you're wondering, no, you don't have to clean the inside of TVs. In fact, in most cases it's not recommended, because what harm does it really do? It's just a personal preference of mine, especially if I'm going to be working on them. It's nice to not get coated in 30 years of dead skin cells from the previous owner. Alright, that'll do it. Think I can live with that. Now moving on to the chassis. You know, I'm not one to just blindly recap these. Sometimes that's a waste of time, and sometimes the capacitors that are already on here are higher quality than the cheapo Scamazon specials that you get. So we'll save recapping for the fault finding stage, if there are faults. But we will look for visual clues that could indicate bad capacitors, like this one right here, which has obviously spilled its guts out. Funny enough, that's one of the Nichicon capacitors. I guess being butted up against this transformer didn't do it any good. Probably an excessive heat thing. So we will of course replace that one. First, let's get this board cleaned up. First, let's get rid of this back plate. Looks like we have 2 screws right here. I'm probably gonna have to unscrew the tuner. See where that gets us. Let's see, got some stuff attached. And that's gonna be the screen and focus control, among other various clip things. Separation achieved. Now let's just give it a good sweeping. Doesn't look like I'm throwing those settings out of whack. Doesn't seem like they're moving, but we gotta do adjustment on this thing anyway. Alright, now let's replace that capacitor. Alright, there's the target. There's one extra thick ground trace. There it is. I actually got super lucky it didn't corrode the board, although that's just a 2-layer board. Wouldn't have been too bad to fix. Let's just clean that up just a little bit, just to make myself feel better. Yeah, see, I got too used to those itty-bitty motherboard traces. Forgot what real traces were like. Gotta increase the heat. There we go, that's good enough. Okay, let's clean off that dead capacitor doo-doo now. Some IPA should do it. That stuff is gooey. Now let's just flush a little down those vias. Just a little flood. Alright, yeah, we should be good now. Let's just sop that up. And in with the new. Now let's get that buttoned up. Now let's clean up our flux, even though old RCA didn't see fit to do that. This board is a fluxy mess. Good enough. Now let's spruce up these RCA connectors. To do that, I like to use a regular deep well socket and some ultra fine steel wool. Just break off a bit of that. Pretty straightforward. Just goes a little something like this. Just put it on there and rotate it. Polishes it right up. Yeah, that's looking better. And the thing you gotta make sure is to get rid of all the little steel wool strands that gets everywhere. Yeah, there's probably a pre-existing tool for this, but I definitely don't have one. But why buy a special tool when this works just fine with stuff I already have on hand? Plenty shiny now. We'll just give the video input a shot of deoxit, since I know I'm going to be using that. Okay, I think we're ready to test this thing. I'm just going to leave that back cover off for right now, just to make it easier to make adjustments and see explosions. Now let's reconnect all the things. Can't forget the zappy boy. Alright, it is testing time. Now, normally I like to soft start old electronics, That just involves putting an incandescent light bulb in line with the AC. But I can't believe how hard it is to find incandescent light bulbs now. Especially those high enough wattage to handle this thing. You can't really soft start sets like these anyway. Pretty sure this has a switch mode power supply, and they don't like weird input voltages. So we're just gonna send it. We're gonna send this thing full mains voltage. Let's see what happens. Okay, nothing terrible yet. Thought I'd hear some relay clicking or something, but we've got nothing. Well, let's hit the power button. Oh, I hear deflection. Yes, we got static. Sounds like it's working. Get that tube to warm up. And look at that, got a picture. Looks like it's really, really misadjusted. Let's turn that annoying volume down. There we go. But you know, I thought I'd get more TV static. That's actually, seems kind of dim. And there's some strange things going on with the deflection. The channel indicator. And deflection is really audible. I don't know if that's coming through on the microphone. I definitely hear it. Okay, let's try sending it a video signal. And for that, I'm going to use this little pattern generator. This thing's super handy. It works great. I'm just going to connect it with composite because I don't feel like bothering with RF. Alright, turn that on. And we'll just stay with color bars for now. See, I guess the video button selects between sources? Maybe not. That is a messy signal though. How do you select input? Oh, it does have some digital stuff. Yeah, there's some weird things going on with deflection. Look at that. Yeah, we might have some fault finding to do. I have no earthly clue how to put this thing on composite mode. See, I'll just scan through the channels. Nope. Usually, sometimes it's at the end, where they loop around. Not this time. Don't tell me you need the remote. See what video reset does. Not doing much. It might be doomed to RF. Okay, it's audio setup menu. Yeah, I don't see any way to choose input. This is terrible. But you know, I see an ever so slight hint of static. Let me go back to that video menu. Let's turn up the brightness. Yeah, there's the static. So I wonder if that's an issue. It might not be. It might just be squelching the noise. Actually, let's set that back to its default. Or I guess we could just do video reset. Why not do that? I'm assuming that's what it does. Okay, there's got to be a way to configure this thing. Let's see. Edit channels, A. Let's go in this direction. No. Not sure how this interface is supposed to work. Okay, channel down. Oh, just timed out. This thing has no patience. Get me back in there. Let's see, down channel. Oh, there it is. Yes, add that channel. Okay, so channel 91. Yeah, we got some significant bleed over between those color bars. Also really shifted to the left. Yeah, we got lots of adjustments to do. See the crosshatch pattern. Yeah, it could be worse. It does look like we have some convergence issues. See the dot pattern. That is making some strange sounds. Seeing some awfully noisy deflection. The staircase pattern. At least black and white looks decent. See the circle. Yeah, lots of convergence issues. Center cross. Well, it's actually somewhat centered. Though it does look like the deflection coil is kind of twisted. See, I didn't even check if that was loose. Let me just go touch some high voltage stuff. What could go wrong? No, it's not loose. Oh well, that's the least of our concerns right now. Let's see, window. It's a window. Alright, raster. You know, this tube is not as bright as I would like. Seems like it could be more of a high hour unit. Let's go adjust the brightness. Yeah, that doesn't look great in person. And of course it timed out. Let's just video reset. Well, you know, even back in its day, this probably wasn't the greatest TV to begin with. And for all I know, it's probably not even a problem with the picture tube. It could be something out of spec on the board. Let's focus on one problem at a time. Let's work on this color bleeding issue. Ooh, what is this? Oh, it's going through the raster. Forgot how to use my own tester. Okay, let's work on this. Okay, I decided to use the bench PC's capture device as sort of a source of truth, and we're getting color bleed there too. I think this might actually just be due to a limitation in the composite signal, in the chroma demodulation or something. Starting to remember how limited this stuff all was. You know, so much of analog video is just get it to be good enough. So I think let's try over S-Video, see if we get any different results. Well, let's see. Yep, had to dig deep to find one of these. Okay, not that deep. I'm kind of a hopeless hoarder. Now, do we get S-Video the same way we got composite? Edit channels. Guessing maybe the channel below this one. Yeah, there it is. Yes, add that. Now go away. Okay, yeah, I don't see much of a difference in the bleed over. It was just a little bit brighter. I can do a side-by-side comparison between composite and S-Video. That is a much cleaner signal. Though I don't know, this colors seem a little dingier on composite. Yeah, S-Video is definitely a lot better though. Okay, so the color bleed problem is probably imaginary. I'm just expecting too much precision from an old CRT. But that's the reason why RGB modding is a thing. These things can be better with better source signals. Let's move on to the convergence problem. See what that looks like. Yeah, we definitely still have a convergence issue, even on S-Video. Let's work on adjusting that. Okay, well, scratch that idea. I didn't notice earlier that this thing had a bonded yoke. That means convergence and purity is set at the factory and is not adjustable. Well, I guess this is just an old consumer-grade TV after all, and this was starting to get into the anti-service era. Well, let's move on to what we can adjust. Alright, the focus is definitely out of whack, so let's see if we can get that to be a little bit better. Gotta try to do this in such a way that I could actually see. So I don't have a mirror set up. Okay, that's sharpening up. Went past it. Let's see. That is probably as good as it gets. Okay, take another pass. We out of focus. Back in, okay. Yeah, that's probably as good as it gets for this set. You'll never get the corners to agree with the center on a CRT, unless it's like an actual decent PVM or something. Consumer grade TV? Forget about it. It's got to be kind of like compromise between the two. I tend to prefer the center. See if I make the corners more in focus, the center gets out of focus. Just annoys me. Rather the focus be in the center. And I'm definitely seeing some jitteriness in the vertical deflection. Let's take a look at that. Let's hit the screen adjustment. Maybe I can get the tube to be a little bit brighter. And that's just showing the background noise. Yeah, no help in that. Okay, well, does our dot pattern look any better? Actually, much better. Alright, so this thing wasn't too bad off at all. Let's see, let's take another look at the position. Yeah, we are definitely crooked. But there's no fixing that. Let's want to figure out how to unbond that yoke, which I don't. At least not right now. Maybe in the future. But I just want to get this thing up and going. So I think it's time we get a real signal in this thing. Introducing the entire reason I'm messing with a CRT television. Yeah, it wasn't just to ward off teenagers in their high-frequency hearing. That's just one of the reasons. But no, I've had this thing for like 8 years now. And I barely ever play it because I can't stand playing it on modern displays with their input lag and lack of light gun ability. And this kit is complete. And everything works, although the edge connector is a little sketchy. Might dig into that. Not sure if I'll do it in this video. Depends on how it goes. It's been a while since I checked up on this thing. Let's get it connected. Now that's an iconic looking duo. Let's power this thing up. And let's go to composite. See if this guy even wants to work. And that's a no. Guess let's do the old edge connector voodoo routine. Nope. Might need some deoxit. Oh, that's a blocker. Let's hit it with a deoxit soaked Q-tip. There's a little bit of nasty stuff. Could be the issue. Yeah, it wasn't the best connector. Let's see what we get now. Give it some harassment for good measure. Okay, now it's even worse. We might be diving into this thing. Give it one more chance. Well, we at least had video corruption last time. Now we have nothing. Well, you know what? It's about time I got into this thing anyway. Let's open it up. Yeah, I'm probably the first person to open this thing. Oh, there's that screw crack I was looking for. Guess Nintendo chose the right kind of plastic. Smaller crack, but still a crack. I don't know why I find that so satisfying. Delicious. And the last one didn't give me one. What's up with that? Yeah, this thing's a mess too. Let's get that shielding off. There's the target, although the problem's unlikely to be this end. It's usually the end where it attaches to the board. So we've got to go deeper. Might as well pull the whole board. That's right, there's a secret edge connector inside. And it doesn't look too bad. We'll get it cleaned up though. First with alcohol. Yeah, pretty dirty. And the other side, slightly more dirty. Now I'll hit it with some deox. Since the alcohol is dry now, and we'll get some down in the connector, why not? And the cartridge end is harder to clean, especially when you lack the correct tools. So I'll make a best effort with a squished Q-tip. Yeah, it's kind of dirty. Let's just deox that too. And we'll just work it on and off. Sounds connected. Let me just wipe this dust off. It's bugging me. And not get it in our nicely cleaned and deoxed connector. Since I'm kind of working backwards, as usual. Might as well polish up those RCA jacks too. And I guess we'll show some love to the RF jack too, why not? No, I won't be using it. Okay, that's enough polishing. Might as well de-dustify the case too. Okay, got that thing back together. Let's try all of this again. Okay, we're still on AV input. Didn't even test this thing before, but I'm confident it will work. Yep, fixed. And I'm mainly doing this as a geometry test. And aside from that tilt, it's not too bad. Oh yeah, the way it was meant to be played. I die immediately. It's been a while. Oh, I'm terrible now. Anyway, let's not get into this. Let's kill that volume so that Nintendo's nuclear lawyers don't come for me. Alright, picture quality, it's pretty acceptable. I guess you can't really expect too much from this type of television. I can see the difference in the detail of the clouds in the middle versus the outer corners. Mario's looking a little unconverged too. But you know, it actually looks way worse in the video. To my actual eyes, actually it looks okay. Or it's what you expect a cheap analog TV to look like. Didn't I send that mushroom? Oh well, I'm running out of time anyway. Okay, well, at least I don't need no geometry updates. Out of time. You know, I was just playing around and got into one of the castle levels, and with that dark background you can really see how bad the convergence is, especially in this corner. It's really too bad that's not adjustable. See, if I hold up a magnetic screwdriver to the back of the tube, just close to it, kind of straightens it out. Really wish that yoke was adjustable. I'm trying to figure out if I can live with that or not. Might be something I could do in circuitry about it. Gotta dig a little. See that, or I just put a magnet on the back of the tube. Call those convergence strips. I don't have any on hand. I haven't had any in a very, very long time. Don't know if I could tolerate that. But actually, you know, the longer I let this thing run, the better the red seems to get. So I think we definitely have some components that are drifting. In the case of the red, they're drifting in the right direction. However, the greens and the blues have gotten significantly worse, and it doesn't seem to matter what position on the screen they're in. Greens bleeding vertically and blues bleeding horizontally. So I think it's time to dig up a schematic. Let's see what happens when I drain the color out. Yeah, see, that should be a fully black and white screen right now. But we've got red bleeding horizontally here, still have the vertical bleeding, and still with the green and blue bleeding, so yeah, we gotta get into the circuit board. Okay, now we should get some sparkage. Yeah! Nice big spark. Just gonna hold that for a few seconds, let it drain. Alright, should be good now. You know what, let's just shove this in there, because these things can build the charge back up while they're sitting. In fact, most capacitors can do that. It won't hurt you, but sure does suck. Especially when you're not expecting it. You also got to watch out for these guys. They'll zap you good. Okay, before I spring for buying the Sam's Photo Fact, let's see what we can figure out without a schematic. Let's start with the neck board. So these three 2.2K resistors, they connect to the RGB cathodes. This one here connects to the screen. So let's just see if they've drifted. Well, got a little bit of drift there, but these are 10% tolerance, so that's kind of on the high end of tolerant. This is the red cathode. The first one was green. So they have drifted, but not by a whole lot. This is the blue cathode up there. Let's check this one's connected to the screen. Yeah, on the high end of drifted, but they're not terrible. These also connect to these 20K ohm resistors. See what they're at. 20K, pretty good. Yeah, these are looking decent. Alright, well, let's follow this down to the chassis then. I'm not going to worry about those being so drifted just yet, but I'll keep it in mind. Okay, here's where the RGB signals come out of the chassis. And unfortunately, they run through a labyrinth of unmarked SMD components, specifically unmarked SMD capacitors. So yeah, might have to dig up a schematic. Okay, I got to thinking about this overnight and started to get the idea that maybe this is a problem with the chroma decoder in the composite section. So I decided to try RF instead, and honestly, it looks so much better. And see if we switch back to composite. Yeah, back to this blown out colors and all kinds of grossness. So our problem is definitely in the composite decoding section, because clearly the CRT and its driving circuits are not at fault. I even tried using the good RCA cables, you know, the kind like you wear on your wedding day. Made no difference at all. Okay, yeah, you know, the more I think about it, the more that makes sense. Or more accurately, the more I remember about how NTSC video works, the more it makes sense. Gotta bear with me here, I'm dusting off some decades-old brain cells. So we're really only seeing it on the edges of the white text, and that could be because white is a hard transition to the maximum luma signal. Maybe that hard transition's causing some signal leakage that's getting misinterpreted as a chroma signal. And that most likely explains why when we drain the color out of the picture that still bleeds off and still keeps its bleeding off color. So yeah, something in the composite filtering can't handle the bandwidth. And I hate to say it, but it's probably bad capacitors. I know the internet's going to be so happy that we're replacing more capacitors, but that is most likely the cause. And I still don't have a schematic, so I try to trace those down manually. And I did fact check the NES using an LCD monitor, and its composite output is absolutely perfect, so it's definitely not the problem. But that means we get to do this again. Oh yeah, some crack-a-lackin' goodness. Okay, so here's the plan. I'm going to trace out the composite input signal, mark some test points on the board to check with the scope, and see if we can identify the point at which the signal starts to look weird. However, speaking of looking weird, doesn't that capacitor there look a little suspicious? It does connect to this delay line. And delay lines are part of the comb filter that separates the chroma and luma signals out of the composite. Now, a peeled back jacket doesn't always indicate a failure, but sometimes it does. But you know what? It's there. I have replacements, so why not replace it? Alright, got that thing desoldered. Yoink! Let's get the new one in. Crazy long leads. Done. Okay, well, this is what flying blind looks like. So I traced the composite signal to various interesting looking points on the board to kind of create some fake test points. So I tapped the composite signal so we can monitor that with one channel of the scope. Also tapped what looks like the video buffer. That way maybe I can just inject some signals in there, see what happens. That always goes well, right? Injecting signals in random places. Also marked out the delay line pins. Why not? Maybe we can find something interesting. And I traced what I think is chroma to pin 49 of the jungle IC, so we can at least see if we're getting any false chroma signals. And I need something to generate a test signal, a very simple test signal that's easy to see on the scope. And for that I'm using this Toshiba satellite, the one that Sergeant Mac sent me. Yeah, you know, I'd figure out a way to sneak a retro computer into this somehow. And why this laptop, you might ask? It's got a composite port. What better system? So I really just need a thin white line on a black background. Figure I can just draw that up in MS Paint, why not? Well, how's this for shaking hands with danger? Don't worry though, I've got my safety 2x4 back there. It's for the safety of the CRT, not for me, because I didn't want it to accidentally bump the neck board. Anyway, let's get this laptop booted up. Running good old Windows 2000. Yeah, don't know what that's about, but that was delayed sound. But let's just go ahead and log in. I don't think there's a password. Selling a driver for an Ethernet card. Okay, let's just ignore that for now. Let's get into Paint. And all I need is a black background with a thin vertical white line. I think old MS Paint can handle that. Let's try to make it as straight as possible. So we want it to be just a little blip on the composite signal. Man, this little touch point is really touchy. There we go. And let's save that. I'm not going through that again. Line. Okay, now I should be able to get rid of the excessive other stuff. Well, those blue borders are kind of annoying, but I was hoping it would be a pure black and white background. That might just be on the LCD, I don't know. Let's see what it looks like on the TV. Not going to be easy at all to film this thing. All cramped up in the corner here. Let's turn it on. Okay, I don't have anything on the screen. What's up with that? I think I gotta hit the display button, probably. Oh, not that one. Yeah, not that one. How many displays does this thing have? Oh, saw some blippage. Yeah, there we go. Don't like that we can see that border, but I should be able to move the mouse, right? Aha! And I gotta do this in such a way that I can't even see. Come on, I just want a line. No, not down, the other way. No, not that way. Sidewards. My control scheme's all off. Can I see it all? Okay, well, I need a mouse cursor off the screen. No, not that far off the screen. This is a pain in the ass. Man, is there no way to hide the mouse cursor? Okay, well, I guess that's as hidden as that's getting. Let's see what it looks like on the scope. Okay, well, that's not as pronounced of a blip as I was hoping. Let's actually pause that. Oh, pause it in a spot where it's not scanning. Okay, well, no, that looks pretty good. Got the color burst here and the front porch sync pulse. So yeah, there's the Luma spike caused by the white line. See, it's just a blip because this represents just one single individual horizontal scan as the electron beam sweeps back and forth in the horizontal plane. And this just paints the beam. At this level, it's considered black. And as it's going, the Luma will spike up. That's about max voltage, probably 1 volt. Which tells the CRT that there's a bright something there to fire the electron gun, or guns, in the case of color TV. And then at the tail end there, it drops below black. And that's the sync pulse. Basically turns off the electron beam so that it has time to sweep back over to the other side of the tube and start the next line. So a massively oversimplified explanation of that. If you want to learn more about NTSC composite signals, I suggest consulting some documentation that can explain it way better than I can. So anyways, I don't see any color information getting imposed here. This is directly at the source signal. So let's get our second channel on. Do 1 volt per division, same settings. Hey, why'd you bug my... Alright, let's start that scanning. Yeah, I gotta do this kind of awkwardly, what for not getting electro killed. So I guess let's go straight for what I think is the chroma signal. Okay, well it looks like, yeah, we are getting a little blip of chroma. It's hard to tell out of the corner of my eye. I have to look at this thing. Switch hands real fast. And then be prepared to pause this. Alright, so let's pause. Oh, and pause in the wrong spot. Okay, well, yeah, there's kind of like a echo. That's weird. And it thinks it's 15 kilohertz. That's even weirder because chroma should modulate at what? Like 3.58 megahertz, I think. I don't remember exactly. I'm not sure what that blip is. That wasn't there before, was it? Let's try to take a few more samples. Okay, well, confirm there is chroma noise where there shouldn't be. But you know, it's also on the input signal, so unless I just happen to hit the part where that little mouse cursor is showing, some bad luck, right? Let me zoom out a little and actually get back on the suspected chroma signal. Let's see. Well, you know, I'm not sure. Not even sure if I'm probing the right spots. Sure would be nice to have a freaking schematic. Well, since we're here, let's just poke and prod around. I'm mostly just playing at this point. See what the pins of the delay line look like. They look like nothing. Oh, there we go. Okay. Okay, so that's like the inverse of the composite signal. That's interesting from a science perspective. About this first delay line, what's that look like? Okay, oh, well, that's really high. At least relatively. I guess it's getting a DC bias. This one is also really high. Yeah, okay. I don't even know what exactly that delay line's doing. Would a comb filter in 1992 have 2 delay lines? Okay, so in this area, I think, I'm not exactly sure what's going on with these 3 diodes, but something's getting split out. See what those look like. Don't know, but it sure looks like it's filtered out the luma there. Out the bottom one. Doesn't look like much, does it? And this one looks like it's also sort of chroma-y. But you know what? Since we're having fun, let's connect the pattern generator. See what the NTSC color bars look like. Power on. Ooh, that looks pretty. Zoom out. Yeah. See, now we can see what the color modulation looks like. So in composite, the color signal is just kind of layered over the luma signal, causes the luma signal to oscillate, and depending on the phase angle difference between that and the color burst, that tells the TV which color to display. And just to show what's actually showing on the screen, it's just the NTSC color bar pattern. I wonder if I can actually see the interference between these two, the transitions. Don't know if my scope software is good enough to zoom in on that. Let's see. Let's see, this area is black because it's at 0.3 volts, I think. So the interference would be in between these 2 points. How do we zoom in on a specific area? I really gotta get a real scope. Let's see. Okay, no, it didn't stay centered. Yeah, I don't think there's any way this thing's gonna be able to see that. But we tried. Let's see what other patterns look like. Why not? We'll go to the crosshatch pattern, and that's what we expect. We just have luma pulses every time it encounters a vertical line. And then every once in a while you should catch the entire thing go high when it's displaying a horizontal line. Yeah, you can see it briefly blip. I can catch it. Yeah, I ain't catching it. Oh, well, yeah, caught one. Okay, well, let's look at the dot pattern. I know that didn't look too great on this TV before, and it kind of still doesn't. Let's freeze frame that. It should look pretty similar to the crosshatch pattern, except staying at the black level most of the time. Can't catch any spikes. Well, anyway, you get the idea. All right, well, let's get some color in here. I'm just gonna scroll through. I'm gonna hit staircase, circle. Nothing interesting there. I want some raster. Okay, that's white raster, so yeah, luma's gonna be high all the time. Let's go to red raster. So we got high red all the time. So this thing doesn't even really have the resolution to show the phase angle difference. I miss my real actual scope. Anyways, you can kind of sort of make it out. Actually, maybe not. The reference marks are kind of awful. Let's zoom out just one more. Okay, well, while we have a red raster on the screen, let's poke around the board and see if I can actually find where chroma and luma separate. Yes, there's 2 transistors up here. They look like they've been reworked. It's hard to see in this video, but the solder blob definitely doesn't look like something a machine would do. So let's poke collector of this one. Okay, and it peeks out. So what is going on there? I better let's just set the probe to 10x. What are you? Well, whatever it is, it's 13 volts. I wonder what's peeking out. What's this one? Also 13 volts. Okay, well, maybe probe at the base? They are not easy to see, are they? Let's see, and that is about 1 volt. Not getting any oscillations. Let's see if I can probe the base here. Oh, nothing interesting there. Oh, and it turns out I mistraced the chroma pin. It connects to that capacitor above the resistor I marked. That's why I was getting weird readings. So let's try again. Alright, so let's put this thing back on color bars and probe that capacitor. And yeah, that looks like chroma signal. And don't know why it jumped up to join channel 1, but yeah, it's the right frequency. So let's switch to something that definitely has no chroma. I guess staircase pattern shouldn't have much chroma anyway. And yeah, No chroma signal there. Okay, so maybe the comb filter is working better than I thought. I don't see any spikes. Oh, slipped off. Let me try to freeze that. Okay, yeah. Save for some weird blippage that's probably just noise. Just trying to zoom in a little. Yeah, chroma signal is flat, which is what it should be for a black and white image. You see the color burst there, so that's getting through, which it should. Okay, well, maybe I was too hard on the old comb filter. Either that or replacing that capacitor actually did something, which I doubt. So here, let's switch back to our laptop, do the line test again. All right, there we go. And now I gotta center it up blindly again. Oh, actually that turned out better than last time. No cursor on the screen at all. All right, back to the scope. Let me probulate chroma capacitor. And yeah, it looks like no chroma. Let's pause. Except for, well, something's getting through. Why can't I select that and see what frequency it is? And I guess I can estimate based on the color burst, right? Zoom in. Yeah, no, there's no way to tell with my limited equipment. Well, that I know of, at least. I don't know, what do you think? Am I being too pedantic? Expecting too much out of what is very average at best TV? But you know, it seems to bleed differently depending on screen position. Like to the left it bleeds more blue, and to the right it bleeds more red. I don't know, this might be a combination of issues. Wish I had a way to display this text over S-video or RF. I really gotta step up my converter modulator game if I'm gonna be playing around with TVs. Oh well, there I go, forgetting who I am again. Of course I have a computer with S-video output. What's the point of being a hoarder if it doesn't occasionally come in handy? Alright, I can already tell that looks better. Well, except the P is bleeding off. Hooray! We found another problem! Okay, so I guess it's going to extend the desktop only. It won't let me clone. So I got to drag paint over there. And, you know, it does look a little bit better. There's less separation, but it's still there. And it's still more blue on that side, but more red on this side. I don't know. Maybe I'm expecting too much of this. But there's that orange bleeding again. Let's see if, ooh, where'd my mouse go? Oh, lost in the other desktop. Yeah. Let's see. Does orange always bleed? It's bleeding down here, but not up here? What? Oh yeah, no. It's bleeding plenty. Bleed over here? No, not really. Not to the same degree. And these deflection artifacts up here, where it gets kind of squiggly, I know from experience there is nothing you can do about that. Old standard def TVs just can't handle that. Precision of computer graphics, perfectly straight lines and all. Okay, I want to get a sense for which colors are responsible for the bleeding. Don't know of a generic test pattern for that, so I created my own fake one. And I want to cover as much screen area as possible because it seems like it's pretty variable based on screen position. So let's drag this over to the TV. And yeah, I can already tell it's pretty bad. Let's maximize that. And it's interesting that the horizontal lines are much brighter than the vertical lines. It tells me there's maybe some timing issues. I mean, obviously it's never going to be perfect because it's just the way these old TVs operate. They never had a thought in their mind to process perfect computer graphics like this. No per pixel accuracy, that wasn't part of the deal. But it certainly seems that red and blue are the culprits. Way worse than green. So there's a number of things that can cause this. So basically it's got to be just a delay in shutting off the electron gun when it, transitions to black. It's not shutting off fast enough. There's a number of things. Maybe the output transistors are getting a little leaky in their old age, or maybe some coupling capacitor somewhere. Maybe a resistor's gone out of spec. But I can't accept that this is just normal, There's got to be a fix for this, or at least a way to improve it. But before we dive back into the chassis and start probing the video output stage, let's try some simple adjustments. Okay, let's start with green drive, although I think green is probably the best of them. I'm trying to remember its position. Let's start turning it all the way down. Okay, well, green's bleeding slightly less. Okay, that's all the way down, and we still got some bleedage. But green's the least troublesome, so let's turn that back up about to where it was. The next one is red-blue drive. They just combine the two. Let's turn that all the way down. And that seems to be making no difference at all, although it's making the blue slightly more red. Alright, and that's max, so no, it's just increasing the overall brightness of the blue. It doesn't really shrink the bleeding. So we'll set that back. That looks pretty good. Okay, now blue bias. The screwdriver just barely thin enough to fit in that potentiometer. I don't have a proper hex one. Alright, let's turn that all the way down. Actually, yeah, that's pretty close to all the way down already. It was like an eighth of a turn. And that, yeah, makes no difference at all to the bleeding, just to the blue bias. Actually, yeah, that being so close to turned all the way down, that's a good sign for the blue gun. Means it's strong. Alright, moving on to green. Turn it, wait, actually, that one is all the way down. Huh, that's the blue gun's strongest of all. Okay, yeah, but that's, yeah, still not making any difference to the bleeding. And finally, red. Take that. Oh, that one's all the way down too. This tube's stronger than I thought. Or at least the electron guns are. Let's turn it all the way up. It's gonna look like everything's in hell. Yeah, not much difference to the bleeding, although something good, interesting's happening around the green. It caused the green to develop a shadow. I gotta think about what, if anything, that means to the problem. Or a supposed problem. But obviously this is not a problem that can be solved with simple adjustments. So let's turn that back all the way down. Alright, yeah, now we're gonna have to start checking signals. Okay, it's time to check the actual signals that we're seeing on the neck board, and thus going into the tube. I guess we'll work backwards from there. So I got color bars back on the screen, and I guess we'll start with blue, since it's right there. This pin connects to the base of the blue output transistor, and that signal comes directly from the video amp on the board. And let's see what we got. And actually, this time I'll set the trigger voltage so eyes aren't jumping around. There we go. Okay, yeah, that's kind of a slow ramp. It's about 1 microsecond or 1,000 nanoseconds. It should be, at least I think it should be way faster than that, right? So yeah, kind of slow to turn on and kind of slow to turn, actually slightly faster to turn off, but still I would like to see a sharper transition there. It looks like it's about 1 microsecond too, because you have to think about the phosphor decay. That phosphor needs time to dim down too, so that adds on to this. So yeah, no, seems like that would cause streaking, right? Not sure which phosphor type this tube uses. So this is just an average set. You know what, let's see what's actually showing up on the cathode pin. Let's see, blue cathode pin is there, which actually connects to this resistor here, so I'll just clamp the board there so I could probably get a better bite. Yeah, there we go. Okay, so it looks like the speed of the output transistor is okay, at least reasonably okay. There's a little bit of a delay there, but it's very, very small. So I think, well, at least the blue output transistor is okay. But this here is actually the on signal because when the cathode voltage drops, that's when it actually fires the beam. So we need to actually be looking here where it turns off. And actually, yeah, there's a little bit of a difference there, isn't there? So this is about the full width of the off signal. And it looks like we've got like maybe a quarter to a half of a microsecond transition time here. That's not good. So this thing could be taking up to like 2,000 nanoseconds to transition. That doesn't seem quite right, but honestly, I'm more interested in why this channel is not transitioning faster. I think if we improve that, then this probably won't matter as much. But since we're here, let's just check the rest of them. We'll move on to red, since it's the next one in the chain. And really no better place to bite onto the red cathode pin, is there? I gotta go straight to the socket. Hope that alligator clip's got plenty of bite in it. Don't worry, it's only a couple hundred volts. Okay, yeah, similar story here, actually a little bit more dramatic. And we've got just the teeny tiniest little tail left. But you know, I'm not sure how much that little bit of difference really matters. I'm far more suspicious of the video amp. Actually, let's go to a pure red raster. And there's one. Okay, now that looks pretty awful. Yeah, there's a lot of drift there. Okay, so maybe there are problems on the neck board. See, this thing doesn't really peak out until here. It's like almost a full, more than 2 microseconds. The video amp shut it off long ago. Okay. Actually, why is that jumping around? Let me stabilize a little. There we go. And yeah, this being a pure red raster, this is actually the start of the horizontal blanking interval. So that would be the sharpest of sharp transitions, because the gun's got to turn completely off and sweep to the other side. Okay, well, it just got slightly more interesting. I'm gonna actually go back to blue and then put a blue raster on the screen. All right, there's blue. Slightly similar story. Got a gun cut here, but we continue to rise. So maybe the pull-up resistor is out of spec? Or maybe leaky snubber capacitor? Because I'm kind of doubtful that it's the transistor itself, although could be. The thing is pretty old. But for these two to be so equal, although I guess blue is slightly worse, isn't it? It's hard to tell, but it seems like they're pretty similarly out of spec. Well, now let's actually look at green. Now put a green raster on the screen. What the? Did I screw something up? Or did I hit the wrong trigger? Or the trigger voltage change? No, that's odd. There's definitely a green raster, but it seems like it's lost my trigger. Voltage is lower. Maybe? Can't even see let's increase the time base. Why are you not triggering? It's not that different in voltage. Let's see if I can actually pause that. Okay, so whatever is different about green is absolutely causing a faster transition on the cathode. And let's go back to 5 microsecond resolution. Alright, so here's cathode transition. This seemed a little bit faster with green. Seems like it's getting it done in about 1.5 microseconds, unless I'm being generous. That could be why we're seeing slightly less streaking with green. Still curious what's going on with my input signal. I'm just going to pop that back on blue real fast. Okay, what changed? Triggering on 5 volts. We're slightly below that on blue. I'll move back to green. Yeah, that's weird. Input signal for green is slightly higher, 5.6. Alright, well, in either case, output from the video amp should definitely be transitioning faster, at least in my opinion. Let's actually go back to blue to make sure I'm still sane. Yeah, fall time should be faster, at least in my opinion. I don't know, maybe that's normal for this set? I would have to trace that signal back all the way to the jungle IC. Okay, here's where those signals originate from the chassis. Looks like they connect directly to the jungle IC through these 3 resistors here. Already checked those resistors and they're in spec. And here's the underside of the board, the 3 wires being here. And I see we have 6 capacitors involved, all surface mount what looks like ceramic. Now if those caps are out of spec, that would certainly affect the rise and fall time, I would think. However, the likelihood of all 3 being exactly out of spec, as it seems to be, combined with ceramic SMD capacitors being pretty robust, it's probably less likely, but I currently don't have much else to go on. So I guess I'll try replacing them, why not? What's the worst that could happen? Some wasted time? Oh, and I finally found a freaking free schematic, and it seems to be definitely for this chassis, so we won't have to guess what the value is of those capacitors. Guess this is like a little RC network or something. And I'm going to start by replacing these three, the 330 picofarad capacitors, see if that makes any difference. And that would be these bottom three here. So work on getting those off. With some flux, of course. And see if the knife edge is enough. Oh, yeah, more than enough. And it's not lost on me that that crystal looks like it's definitely been replaced. That is not a factory solder job. But I think that's the least of our concerns right now. Alright, well that came off a little bit more gently. And here's the last one of the 330s. Okay, now I gotta do something stupid, because I don't have SMD replacements for these. So I'm gonna surface mount a through-hole capacitor, just to see if this has any effect at all. I really wish I had a way to test these, but I do not currently. But I want to see if this works before I buy the SMD equivalents. And this is going to take some precision soldering, so the camera's going to have to get out of my way. Thanks, I hate it too. Well, let's see if that did anything at all. And figured I'd video first power on, just in case there's an explosion. So let's see. Hey, no explosions. Yet. Well, the good news is, it doesn't look any worse. Yeah, I kind of had my doubts, since it seemed unlikely that they were all out of spec equally. But I don't know. I wonder if we should try to replace the 270 picofarad caps. Or maybe I'll just replace one, maybe for red, since that seems to be the most prominently bad one. Yeah, you know what? Why not? Let's do it. Oh, and if you thought that was stupid, get a load of this. Yeah, I don't have a single 270 picofarad capacitor, so I had to put a 220 and 47 in parallel. Oh, and I decided to put it on the blue channel instead for the sake of convenience, because the cap for the red one is like right here and way too close to these. And blue seems almost just as streaky as red, so let's see. Explosion cam? Nope. Okay, now blue is dead, and what's left of it is extra streaky, so hooray! We fixed it so much that we broke it. That's fine, I can just put that capacitor back in. Oh well, you know what, that gives me an idea. I'm gonna try actually lowering the capacitance, because less capacitance should mean sharper rise and fall time, right? So I've just removed the 47 picofarad capacitor. Let's see if anything's different. Explosions? Aww. Okay, now that's looking very much like it did before. Or, dare I say, maybe slightly better. Hard to tell. Well, shall we go even lower? Problem is, my next value down is 100 picofarads. Oh, and I just realized I'm an idiot. I had a 47 nanofarad capacitor in there. So yeah, no wonder we lost blue. The timing must have been ridiculous. Anyways, I decided instead of lowering the 220, I'll instead lower the 330 down to 220, since the cumulative effect should be about the same, though it's been a very long time since I've looked at the underlying mathematics of RC circuits. But it's soldered on there, so let's see what happens. Explosion cam. Not this time. And that is causing even more slightly less streaking. It's very subtle, but there's definitely less than before. So, you know what? Why not throw the 100 picofarad in there? See what it does. And I'm putting it in place of the 220 on this side. Why not? Explosion on. Nah. Okay, I think we've reached diminishing returns on that idea. Seeing only very, very marginal improvement. But with me having to drive this so far out of spec, definitely points to another problem. Because I shouldn't have had to cut these values so much to get it to look even a little better. But I guess I'll do the same thing for red, since that one's really bad. Okay, I decided to go ham and replace the 100 picofarad capacitors with 47. And actually, this thing looks fantastic now, at least compared to what it did. So blue isn't improving a whole lot further, but red has significantly improved. That has never looked this good throughout the 2 days I've been messing with this thing. You know, I really wish I had some variable capacitors in this range. I don't even know if those exist in the picofarad range. So I can just put them on there and tweak it until I find the right setting, but I really shouldn't have to be dropping these values so low. There is something else wrong with this thing. Although I am going from tiny SMDs to these long-legged Bojack capacitors from Scamazon. I'm not kidding. They're actually called Bojack. So maybe they're adding some stray capacitance that, is getting compensated for by dropping their actual values. I don't know. Gonna have to order some SMDs. But honestly, this video is probably well over an hour long by now, and I really gotta move along to other things. But I still think there's probably some deeper issue causing this. However, for right now, I'd say it's pretty good. Okay, I couldn't leave it alone. So here's a before and after. I settled on 110 picofarad capacitors. And the bleeding's not completely gone, but there's absolutely a noticeable improvement, especially for red and the edges of the screen. Now, I went as low as 47 in place of the 100, but that didn't look much different, so I guess we're hitting the limits of either the tube, the jungle IC, or this particular RC network. And I really don't want to go that low anyway, because I don't want to start losing any noise filtering characteristics. But it does make me wonder what could be accomplished with better signal handling off the jungle IC. Maybe some of you math magicians can suggest some different component values. Now, obviously this is never going to be some high-resolution monitor. Displaying the hard transition of computer graphics is a tall ask for any standard def CRT television. But I do wonder what it would take for this thing to be all it can be. Alright, back on the NES. Yeah, this thing looks so much better, save for the fact that we're on RF. Composite still looks pretty bad with all the chroma luma leakage. But yeah, it's hard to catch it on camera, but to my eyes, this thing looks exactly how I expect it to look. It's giving me those nostalgic feels. Even the RF noise seems kinda warm and homey. So anyways, I guess I'll call this thing done until I get proper SMD capacitors. And there may or may not be an S-Video mod in the future of that NES. But I don't know. I think a perfectly clean signal from here kinda defeats the purpose, right? Like, this is how I remember these TVs looking while playing these games. Because I always played them over RF anyway. Although there is something to be said about the impressive sharpness of composite now. Now that it doesn't have all that bleeding. Still got a little dot crawl though, but I don't think there's anything we can do about that. I do have to fix this though. Vertical size is just a smidge too small. There we go. And I just checked actual standard def video, and it looks utterly fantastic. That's exactly how I expect it to look. I guess that comb filter wasn't actually that bad at all. These are just some home movies of my extended family. And no, that's not me as a kid. Yeah, I had to dig up the old VCR. So yeah, for displaying actual standard def video like this TV was designed for, it is performing absolutely adequately. And I think that's all I need from it. And this video is coming over composite. And one final thing, let's get these stickers back on there. Got some archival glue for that. You wouldn't want the next guy getting X-radiated now, would you? The most challenging part of the repair. Not getting glue all over my hands. But honestly, that was so much fun. It was kind of like an analog vacation. And to the regular viewers of the channel, don't worry, I haven't abandoned the computers. I still have hundreds of those to go through. But every once in a while, I'm gonna pepper in something like this, like an old TV or radio, especially tube radios. I really like working on those. And this is all stuff I haven't touched in over 20 years, so it's nostalgic for me in its own special way. But yeah, with more than 20 years in the difference, I've got a lot more to remember and more to learn about these sets. Because I'm still not completely sure why replacing those capacitors was necessary. Or maybe it wasn't necessary. Maybe that jungle IC is just so bandwidth limited that it couldn't handle it, and that was just totally normal operation. But if you have any insight into that, I would certainly appreciate a comment. So every once in a while, I'll make that like a Wednesday midweek release or something, because I really don't come across stuff like this very often. I don't see myself finding massive hauls of these like I do with the computers. Yet. But yeah, I think they'd make a really cool midweek release. Something I'll aim for if I ever get to do this full time. And to all the people helping me reach that goal, patrons and channel supporters, thank you all so much. You're all incredibly awesome. Now, if you'll excuse me, I've got some business to take care of. Yeah, thought you were safe back in 1995, huh? Well, I'm back now. Thought you could hide behind those digital screens. You can hide no more. What? I think the sights are off on this thing. Anyways, thanks so much for watching.